We're going to go through examples of cloud services and look at how they're secured and what are our responsibilities and what does the cloud service provider offer us in order to operate in their environment securely. So Amazon Web Services, or AWS, is really a market leader in infrastructure as a service. So remember our models from before. This is infrastructure as a service. So with this type of model, we bear a lot of responsibility in terms of configuration of our systems, our computers, our instances, our virtual machines, the data that's stored. So they are an infrastructure as a service, and they're a public cloud service. So if we make a mistake, our data could be exposed to the public internet. And so stakes are kind of high in Amazon Web Services, and we want to make sure that it's secure if we're using AWS. But they are a market leader, so it bears us looking at them as part of this session. AWS has a super scalable, high availability global infrastructure that's broken across multiple regions with multiple availability zones. So regions are these geographical regions with 2 or more availability zones. Each availability zone really a separate data center. And so there are multiple data centers in a region, and they call them a region, and certain types of reliability can be provided within that region. And we may choose a region to operate in AWS because we want our data or our service or our application to run geographically close to maybe where the users may be accessing it. Availability zones are physically separate, many miles apart data centers that are redundant, and it requires multiple data centers in a geographical area there to be called an availability zone. And then we can look at the AWS Service Health Dashboard website to give us an indication as to how these are operating and whether they're green or red. But if we can definitely build a very high available application across AWS infrastructure if we build it correct and we're using multiple availability zones and multiple regions and so forth. And there's certain applications and components of AWS that allow us to do that. AWS possesses almost all the major security certifications and attestations. They're a FedRAMP, a FIPS, ITAR, FISMA, NIST requirements, certified cloud service provider, and many others. They have just about every certification. And AWS recognizes that because they're public cloud infrastructure as a service, they need to be very secure, and insecurities on their part would lead to breaches that would be public knowledge and would affect future customers using their services. So AWS definitely recognizes the importance of security. It's something they take very seriously, and they want to make sure is preserved so that they can continue to be the market leader in this space. So AWS has this shared security model that defines the responsibilities for themselves as well as the customer. And so the shared security model helps customers recognize what they need to do and what AWS is going to do for them to help make the infrastructure secure. AWS takes care of a lot of the global infrastructure that we talked about, making sure that that is high available. AWS also performs the foundational services, the computers, the storage, database, and networking. AWS takes care of the security of the cloud, and the customer is really required to define their controls of operating in the cloud. So the infrastructure being the network, the configurations, data, and access, and then the applications that the customer runs are the responsibility of the customer. So everything above that orange box at the bottom is the customer's responsibility. And this also changes depending on what types of services you may be consuming from AWS. If you're just consuming infrastructure as a service services, then this shared responsibility model for infrastructure services is used. If you're using a container service like RDS, the database service, then AWS provides the platform and application management. AWS manages the operating system and the network configuration for that container service. So AWS is taking on a little bit more responsibility for a container service. And then if you have an abstracted service like DynamoDB or Lambda or something like that, Then AWS provides even more of the responsibility, plus server-side encryption for the platform, network traffic protection for the platform. So the platform that you're using, then AWS takes a little bit more responsibility for some of those abstracted services. So it depends on which type of service you're consuming, whether it's infrastructure, container, or abstracted. If you're using infrastructure services, then you as the customer bear the most responsibility. And if you're using something like S3 or EC2, Simple Storage Service or Elastic Compute Service, then you bear more responsibility with an infrastructure service. So it also depends on which of AWS's services you're consuming may change how you're having to secure that infrastructure or that particular application type. AWS provides some valuable security white papers, and much of this is on their website because AWS may or may not have a help desk that you can call. They really try and put a lot of effort into documenting their security information on their website. So if you go to aws.amazon.com/security, there's a lot of their documentation out there that can give you guidance. There's an introduction to AWS security, which is a simple paper that gives you kind of the high-level view of the shared security model. There's an overview of security processes. This is a little bit more detailed document about how they operate. AWS security best practices. This is a great document, spells out many of the details about security, your responsibility, how the different security components and characteristics are provided by AWS or by you, and gives you pointers to other documents to look for, other guidelines. And if risk and compliance is something you're interested in, they have a white paper for that as well. So AWS really tries to provide a lot of this information on their website, so it relieves them from having to, help all their customers. They document a lot of this information on their website. And then each particular AWS service has its own page, its own best practices, its own security guides. So these are all on their website, available to look at and download and use for free. One of the key things when operating in AWS is the identity and access management practices used. So IAM is really this practice of defining who of your IT administrators have access to control which types of functions and make which kind of configuration settings in the infrastructure that you're consuming. So you define users, groups, permissions, and these keys and these access keys for API calls, and you want to restrict those so that you're giving administrators only the level of access they need to configure the resources they need and no more, which kind of contains the blast radius. If one user gets their credentials compromised, then it limits what that attacker could do. So you really want to lock down this master account, this root account, and tie it with two-factor authentication and lock that down, and only use that when you're doing major account changes or configuration settings. And then have really developer accounts, administrator accounts only have the specific privileges that they need. So this is really a best practices that Amazon hits on quite frequently in their trainings. It's really about identity, which access you give which person, and you can lock them down so that only particular administrators can have read access to S3 resources. And you can create these access keys and these accounts. You can tie them to EC2 images, so that EC2 compute image only has access to do certain types of functions. You could tie it down to particular APIs. You can rotate keys, and so it's helping you be secure. And there's best practices around using IAM. AWS offers multi-factor authentication and recommends that for the master account, so you can tie that to multi-factor, either a text page or another kind of factor that's used to authenticate that user. So AWS also offers a secure token service, STS. There's a web service that grants temporary requests for IAM users. So it gives them only very short-term limited privileges to do specific tasks, and then it times that out. The MFA gives you a text with a 6-digit single-use code that's based on the time-based one-time password algorithm, TOTP, RSC 6238 that defines, how these one-time passwords are used. So a very secure method. And so if you have a username or password that get compromised, but with multi-factor authentication, it wouldn't compromise the whole account. So just another level. So even if a computer got infected with malware that had a keylogger, because it's using multi-factor authentication, the keylogger would only capture the one-time single-use code and wouldn't compromise the entire password. So every time, so even if a computer was infected and someone was observing what the administrator was typing, it wouldn't be compromised. Federated Identity and Access Management Console and APIs allow you to extend your Microsoft Active Directory domain. If that's your source of record for usernames and passwords and privileges and groups and accounts, that can be extended with Secure Access Markup Language, SAML, OpenID, and others. You can extend the federation of identity, from your infrastructure into AWS. So knowing who has access to what in your infrastructure is really important, and that's done with IAM groups and roles. In AWS, you're only as secure as your Amazon Machine Image, your AMI. That's the instance file that defines the operation of the operating system. It is possible to build your own images and then save them and reuse them and launch other services off of those images. You can build your own off of a default Amazon Machine Image, or you can import your own if you have a particular security technical implementation guide, a STIG, for the requirements that you have to harden your operating systems. You could do that in this way. But when you're storing images, you want to be careful that you don't store the security keys within the image, because then if you share that image in a community, then your keys can be disclosed inadvertently. The AWS Marketplace also offers hardened images. You can buy these from other companies, preset, pre-hardened operating system images for a wide variety of operating systems, and they've already been locked down per certain security standards. So Buddha Labs offers these hardened images that are based on a DISA STIG. So if you're a federal organization, you could look at using theirs, possibly. Something you can just purchase off the AWS Marketplace for a fee. In Amazon Web Services, there's this concept called the virtual private cloud. It's really your connectivity, your private connectivity, and the way you do secure zoning and network segmentation in your cloud. And there are best practices around how you configure your VPC, and this defines the connectivity that you would have to AWS. You want to be careful how you document and use internet gateways, virtual private gateways, customer gateways, and connect up to AWS, how you connect this VPC to the internet, and your systems are going to be running in this VPC environment. So this is like your routed infrastructure that deals with IP addresses, private public IP addresses, network address translation. The design of your VPC is really important to the security of how you operate in an AWS infrastructure. You want to be sure you put different systems into different security groups, load balancers, web servers, databases, and different tiers of your traditional three-tiered architecture should be in different security groups, so they have only the permissions that they need to operate. And security groups are much like stateful firewalls and have whitelist behavior. They only permit, what you tell it, and everything else is denied. So you want to create these security groups with the minimum number of applications or TCP/UDP port numbers required for the application to function, as required. So you can think of them as a fully stateful firewall, and you may not have the flexibility today in your on-premise infrastructure to build a stateful firewall in front of each EC2 instance, but in AWS you can really control this with security groups and maybe in the end have a more secure environment than you have today in your traditional on-premise data center, where you're really relying on the security of your perimeter and the fact that many organizations have seen erosion of the security perimeter weaken their security defenses. In AWS, it's like having a perimeter at every layer in the three-tiered architecture. So this may actually allow you to operate more securely in a cloud environment. Network access control lists are stateless. They're non-stateful, they're directional, they work like an access control list, much like on a traditional network equipment router. They can also complement what you're doing with security groups. And there are web application firewalls available in AWS also to protect web applications that may be vulnerable to cross-site scripting, buffer overflow, SQL injection type attacks. So AWS and how you connect your AWS resources to the internet is important to document and understand and secure, but then also the ability to use security groups, network access control lists, give you the ability to create enforcement points for your security policy in AWS infrastructure. AWS also offers certificate management to manage your TLS or SSL certificates. And TLS should be used for all of these services. So you want to make sure you're encrypting your data in the cloud and using encryption for data in transit as well. Encryption services are provided by AWS, but you can use them, but really depends on the security of the key that's important. And so to operate them, you have to secure the key. Amazon Web Services offers a hardware security module, an HSM, which is a hardware-based method to encrypt and store the private keys. And it's done with a hardware system in their infrastructure that locks these down, that's tamper-proof, that can't be attacked. And so there's a cloud HSM that AWS offers that can help you secure your keys. AWS also offers services to assist with backups. It's very easy to do backups and snapshots of your images. Glacier is AWS's long-term storage that you can archive and vault data into and store it there for long-term use. It's a little slower and more expensive to retrieve the data from it, but that's the long-term storage. If you want to put stuff there, logs, historical information, create backups, and put them on ice, if you will, for long-term storage, Glacier may be something you could use. It's a very low-cost storage platform and it's secured as well in AWS infrastructure. If you desire faster rotation, if something goes wrong, then you might be able to use bucket policies or Elastic File System, EFS. You can store things and files in S3, which is their file-based simple storage service as well. And you can create policies and bucket policies to control who can access that data. So you've got a lot of policy configurations. You can tie those to IAM roles. You can tie them to security groups. You can lock those down. And you can create different snapshots and do incremental backups. Everything that you do today, but might even be easier in an AWS infrastructure. AWS offers systems to help you manage your security. AWS has a Amazon Inspector platform that allows you to look at your infrastructure and see what are you doing compared to the industry best practices or AWS's best practices and give you some prioritized tips for improvement. So an automated system that'll look through all of your configurations. It'll give you ideas on, oh, this security group's a little weak. This could be improved. You're using your root credentials over here, and give you advice on how to lock that down. AWS offers config rules as a way to help you monitor your inventory, perform change management, and it's recorded in AWS config, all of those changes, so you can go back and you have some audit trail to see what was done. If there was a mistake made or there was an attack that was performed, you could gain visibility into it, or maybe there's a malicious insider. AWS config rules may give you visibility into what's happening there. An AWS Trusted Advisor is a service. If you're a business or enterprise support customer, you can get access to Trusted Advisor that'll review your settings and give you areas for improvement as well. So AWS recognizes the importance of security to their customers and wants to give you these automated tools to help you self-assess how you're using AWS services securely and give you recommendations or opportunities for improvement. But really, AWS, because it's a shared security model, it's infrastructure as a service, it's public, and it's a shared security model, it really requires ever vigilance. So you need to really be paying attention to what's happening in your infrastructure. It has a cost implication to you on a month-to-month basis, and so you want to be attentive to what's happening. And a simple mistake in a security setting can really cause a large exposure for your organization. So you need to be very careful with all of these settings. And you can see that because it's infrastructure as a service, it's public cloud infrastructure, it's a shared security model, a customer bears a lot of responsibility. So there's a lot of settings to keep track of. AWS offers CloudWatch, which gives you visibility and polling into your metrics, logs, alarms. Standard is a 5-minute polling interval, but you can get detailed 1-minute polling on statistics and metrics of your environment. There's an added cost to having the increased resolution and granularity of the metrics, but can give you visibility and maybe early warning that something's happening. CloudTrail is an AWS service that provides all the detailed logging, auditing of exactly everything that took place in your AWS environment. It records the API events, API calls, changes, tracking, everything, and gives you all of this data for security forensic purposes, but also operation forensic as well. So you can detect abuse, other kinds of problems, detect attacks, detect insider threats, detect other kinds of things that may not be configured properly through AWS CloudTrail. So a lot of data. And there are other systems that interact with AWS CloudTrail that you can use as well. You can report abuse, report vulnerabilities to AWS, and they'll take your suggestions and with their engineering team continue to evolve and improve the security of AWS infrastructure, their responsibility portion of that. Also, if you want to perform a vulnerability scan or a port scan of your infrastructure in AWS, you must first get permission to do so. So there's also a means to do that through their website. But AWS will provide the distributed denial of service, man-in-the-middle, IP spoofing, port scanning, packet sniffing. They'll provide those features for you. You don't need to do those things yourselves, but you could request these things be performed on your behalf. So, like we've seen before, AWS, a lot of security, the options that they provide, but much of that is the responsibility of the customer to have it set up correctly. AWS has this security ecosystem. They work with many partners. They're the major market leader, so they have the largest ecosystem and set of vendors that complement and extend what they do. And I mentioned the AWS Marketplace, a place where you can consume other cloud services that can complement what you're doing with AWS's native settings. So now, after looking at AWS, now let's consider Microsoft Azure Cloud Services. Azure, also a leading cloud computing service provider. They provide platform and infrastructure as a service services. So depending on the nature of what you're consuming, you may have a more platform as a service type security model here. Microsoft Azure has a full set of compliance certifications, much like AWS. They're also FedRAMP certified. So if you want to operate in Azure services when you're signing up, you want to make sure that you're operating in their FedRAMP version of their cloud or the instance of their cloud that is secured for federal workloads. Microsoft follows their own secure development lifecycle and operational security assurance, OSA processes. So the software that they're developing for Microsoft Azure are the same processes they use when they develop any type of software. So Microsoft, much like AWS, very secure coding practices on their behalf to make sure that they anticipate what attackers could do, lock down the code ahead of time to minimize attacks as best they can. Microsoft offers AD authentication and integration, two-factor authentication, encryption, DDoS prevention. They offer a key vault that's also a FIPS certified hardware security module, HSM. There's a Microsoft Azure Trust Center that gives you visibility into how you're operating. It gives you a dashboard for understanding your security settings and everything like that. And Microsoft offers Azure Security Center, gives you this visibility in this dashboard, and it's integrated in with Microsoft Global Threat Intelligence. So They understand the current threats on the internet and who's attacking who moment by moment, and that intelligence about current attacks on the internet is fed automatically into their system, and you benefit from that up to the moment security research that they're performing to help you defend your applications running in Azure cloud services. So Azure, much the same way as AWS, infrastructure as a service, it's a shared security model. You need to secure your applications you're running there. You need to secure your data, but Azure can provide a little bit more if it's a platform as a service type service you're consuming from them. Another complement, you can see the differences in the styles. Google Cloud Platform Security is infrastructure as a service cloud service provider. They leverage their own infrastructure that Google uses for search and YouTube and their other applications they make publicly available. And they offer that for rent. That pool of resources can be rented and measured service as a cloud service. Like other infrastructure as a service platforms, it's a shared security model. The customer bears responsibility to secure how they're using those cloud services, and Google provides you tools and capabilities to secure that. Google has many of the common accreditations, PCI, SOC, but they don't have FedRAMP accreditation. To my knowledge, it's probably in process. They're ISO certified. They have the FISMA moderate compliance. So you see it's a little different. And Google doesn't have quite as much documentation out there available to their customers as AWS. So you, in a shared security model, bear even more responsibility to go and figure out how you're going to operate securely in a Google platform security. And this is true even more so with DigitalOcean. DigitalOcean is really a popular development environment for DevOps organizations developing web applications. It's a public cloud infrastructure where you on your own, you can make your own web applications secure. It's really up to you to make sure your web applications are secure. They publish some privacy policies. They have some very basic cloud security information on their website, but not much documentation. And you bear a lot of responsibility here and when using their services. So it's even more so up to your application developers, your DevOps teams to consume their resources securely. It's infrastructure, you're building web applications, but you're left to your own resources to make sure that it's secure. You don't get very much assistance. So compare and contrast that with AWS or Microsoft Azure. With Salesforce.com, they're a cloud CRM SaaS provider. That's how they kind of started out. They offer other cloud services as well. But because it's a software as a service provider, as an example, much of the responsibility for securing the infrastructure falls on Salesforce.com. You as the customer are really just eating the pizza at the pizza restaurant. So it's up to Salesforce.com to secure all of the infrastructure, the application, the compute, the storage, the network virtualization, and the multi-tenancy. You're just more interested in consuming that application and the storage of your data in the cloud. Salesforce.com has a mature set of security practices throughout their whole company. Security is very much woven into everything their development teams do. But you do have to understand your responsibilities. You're responsible for user authentication, so who's getting access to those software as a service services. And you can do that with SAML, OAuth, roles, permissions. You have to grant who has access to what. Administrator accesses, user accesses, you define those. You're also responsible for your data security and who you share that with, and any other third-party tools that tie into that Salesforce data set are also your responsibility. Programmatic security, if you're writing certain type of SOAP APIs, metadata APIs, if you're writing your own code, the security of your code is your responsibility. And Force.com, there's a security code scanner that can look through your code and give you critiques and help you write secure code. So Salesforce.com, a SaaS provider, you can see the differences in the shared responsibility model here compared to infrastructure as a service as like AWS. You can see that Salesforce bears more responsibility here. You don't have to worry about nearly as much with a SaaS provider platform when it comes to security. When it comes to cloud storage, I mean, we mentioned earlier that there were many breaches in terms of cloud storage solutions that led to, data leakage, and these have been documented and popularized in the news and the media. If our organization is going to use a cloud storage platform, we want to make sure that we're using that securely as well. And there are some common methods to securing data in the cloud. We want to make sure we're using multi-factor authentication, that we're tying that to a token, a one-time password, or something biometric. And if we're doing single sign-on or federated identity management, that we do that in a secure way. We want to make sure we have audit trails. We know who's accessing which files and folders, and audit trails just from revision control and versioning of files that we may be storing in a cloud storage environment. Reporting, logging on those files that are stored and who accesses them is important if we do have a security incident to go back and investigate. There's role-based access controls oftenly provided by these cloud storage providers, and access policies. We can define who has access to which files. We also have the ability to create policies around what types of data, and if we have secure watermarking, if we watermark and mark certain files based on their classification of confidentiality, if we have a high-quality cloud storage provider, they can monitor those watermarkings and make sure that documents that are marked company confidential are only accessed by corporate executives and not by the general public. So they can also watch, based on data classification and marking, who's using what types of data, and identify and alert you to the fact that there may be a confidential document that's shared in a public way on their infrastructure to help you know that sooner and go and remove that file or clean up any kind of data exposure that might have occurred as part of that. You can encrypt the data, and if you encrypt the data, you want to make sure that you as the customer are retaining control of the key. You want to make sure there's data integrity, that those content security policies are being enforced, and you may encrypt the file prior to sending it to the cloud storage provider. So if you encrypt the file with your keys, you store that file on that cloud storage provider's infrastructure. If that file is leaked inadvertently, the file is already encrypted, so there's no exposure. A new concept in cloud storage security is this concept of data dispersion. Use 3 or 4 different cloud storage security providers and store a portion of files across all 4 providers. So if any one of those cloud storage providers has a compromise, they don't get the whole data set, or they only get a portion of a file that's not really usable. So data dispersion is another technique for spreading out your risk. And there are starting to be systems and services you can consume that do data dispersion. But if you're going to use a cloud storage provider, you want to make sure that it's certified, that it operates in secured locations, in data centers that are tier 3, tier 4 data centers, where they have redundant systems, they're constantly monitoring. And then when that service provider has a failed hard drive, you want to make sure they're following media destruction guidelines and destroying that hard drive per your requirements. Just as if you were to have a failed hard drive, if it contained confidential data, you would want to make sure it got destroyed in a proper manner. You'd want to make sure those cloud storage providers are following those same best practices.